For decades, scientists have warned that climate change is pushing Earth toward dangerous temperature increases. Rising sea levels, extreme weather, and shifting ecosystems threaten our way of life. But what if we could block just a fraction of the sun's energy before it even reaches Earth? That's the idea behind a space sunshade, an enormous structure positioned between the Earth and the sun, designed to reduce the amount of solar radiation hitting our planet. It sounds like science fiction, but the concept has been seriously discussed by scientists and engineers for years. Could this be our ultimate tool to fight global warming? The idea of controlling sunlight isn't new. In fact, discussions about geoengineering, deliberately altering the Earth's environment, go back at least a century. But the modern idea of a space-based sunshade started gaining traction in the 1980s. Physicist James Early was one of the first to propose using a giant glass shield in space to reflect sunlight away from Earth. Then, in the early 2000s, astronomer Roger Angel suggested launching trillions of tiny reflective spacecraft to form a giant adjustable cloud that could deflect enough sunlight to counteract climate change. More recently, NASA and other researchers have studied the feasibility of placing a sunshade at the Lagrange point L1, a stable gravitational spot between Earth and the Sun, about 1.5 million kilometers, or nearly a million miles, away. From here, the sunshade could block about 1 to 2% of incoming sunlight, enough to lower Earth's temperature significantly over time. Scientists have proposed several ways to achieve this massive feat. A single giant reflective disk. One idea is to launch a single, enormous, ultra-thin reflective sheet, possibly made from lightweight materials like graphene or mylar. This would be like placing sunglasses in space, reducing solar intensity. 2. A cloud of tiny particles. Another idea is to release trillions of tiny dust-like particles or microsatellites that could form a diffuse, adjustable cloud. The advantage? The system could self-correct by shifting its position in response to changes in climate conditions. 3. Swarm of reflective satellites. A more high-tech approach would involve an AI-controlled swarm of small, autonomous spacecraft equipped with mirrors. These could move independently to adjust coverage based on Earth's needs. 4. Lunar or asteroid dust. Some scientists suggest mining lunar soil or asteroid material and launching it into space to create a natural dust cloud. This would be cheaper than launching an artificial structure, but harder to control. Each of these ideas has unique advantages, but they all come with enormous challenges. Let's be real. Building a space sunshade would be one of the most ambitious projects humanity has ever attempted. Here are the biggest obstacles. Launch and assembly. The sheer size of the structure means we'd need thousands, if not millions, of launches to transport the materials into space. Alternatively, we'd need to build it using a future space elevator or advanced in-space manufacturing techniques. Durability. A sunshade would need to survive extreme space conditions, including radiation, micrometeorites, and temperature fluctuations. Over time, wear and tear could degrade its effectiveness. Energy and control. If the sunshade uses small satellites or self-adjusting mirrors, they would need a power source. Solar power is an option, but controlling an autonomous fleet of satellites across millions of kilometers would be a logistical nightmare. Geopolitical issues. Who controls the sunshade? If one country builds it, others might see it as a threat. What if an unintended side effect disrupts weather patterns in one part of the world, but benefits another? These ethical questions must be answered before moving forward. A properly designed sunshade could slow or even halt global warming. By reducing solar radiation by just 1 to 2%, we could stabilize global temperatures, giving us more time to transition to clean energy and develop carbon capture technologies. However, there are risks. A sunshade doesn't solve the root cause of climate change, greenhouse gas emissions. If we relied too much on it, we might neglect reducing fossil fuel use. Another concern is termination shock. If the sunshade failed or was suddenly removed, the planet could experience rapid, catastrophic warming. Climate systems would be thrown into chaos. Right now, we don't have the technology to build a space sunshade on this scale, but we're making progress. Advancements in nanomaterials, AI-controlled satellites, and space-based solar power could bring this closer to reality. Some researchers suggest we start small, testing miniature versions in orbit to see how they interact with Earth's climate. Others argue that while space sunshades are fascinating, we should focus on proven solutions like reforestation, carbon capture, and renewable energy first. Regardless of the approach, one thing is clear: we need bold, innovative ideas to fight climate change, and a space sunshade might just be one piece of the puzzle. Is a space sunshade a brilliant idea or a sci-fi fantasy? Could we build it in the next 50 years? Let me know your thoughts in the comments. And if you enjoyed this deep dive into futuristic climate solutions, don't forget to like, subscribe, and turn on notifications so you don't miss our next video. Thanks for watching, and I'll see you in the next one.